AWS has over 200 services, and if you're trying to break into cloud or level up your career by learning AWS, you've probably looked at this list and thought, hang on a minute, where do I even start? At least that's how I felt when I started. In this video, I'm ranking every single AWS service from S tier, the ones you absolutely need to master, all the way down to F tier, the ones that you can ignore. And I'm not ranking them based on what looks good on a resume or what AWS wants to promote. This is based on what I've seen that actually matters in real production environments and my day-to-day work as a cloud engineer. Hi, I'm Suleiman. I've been working in tech since 2015 at just 18 years old. From there, I worked my way up to earning multiple six figures, and now I'm running my own businesses across cloud and AI consulting, software, and my academy, where I've helped more than 900 IT pros, engineers, and career switchers master cloud and AI and land roles at big tech companies, including AWS. Now, our ranking criteria for each service is as follows. Firstly, how often you actually use it on the job. Is this something that you would use every day, or is it something that you set up once and forget about? Secondly, does it come up in job interviews? Because you can know a service inside out, but if no one's testing you on it, then you don't need to know it. Thirdly, how much do you actually need to know? And this is where most people waste their time. They go deep on services that only need a service level understanding, and then they completely skip the ones where depth is what actually gets you hired. Let's start with security and identity, and specifically IAM, which stands for Identity and Access Management, and it controls who can do what, where, and when across your entire AWS environment. Now, think of it like the master key for an entire building. Every door, every room, every floor has its own lock, and IAM is what decides who gets which keys. And it's not just people, it's also applications, automated scripts, and services that all need the right permissions to function. Now, every single action taken in AWS is governed by IAM. In terms of how often you'll use this on the job, is every single day without exception. IAM is not something that you learn once and then you move on from. Every single project, every single deployment, and every single new service that you spin up starts with this question: what permissions does this need? And what permissions should it absolutely not have? We had a client, fairly mature company, been on AWS for a few years. Now, during an audit, we found a service role that had been given full admin access. That means it had permissions to do literally anything in the account: create resources, delete resources, modify security settings, everything you can imagine. Now, when we asked about it, nobody could even remember why it was set up that way. The developer who had originally created it had left the company over a year ago, and that role had been sitting there for months with permissions that could have wiped out their entire production environment if it was ever compromised. And that happens way more often than you think. Now, does it come up in interviews? It's actually one of the most tested topics in cloud engineering interviews, because they want to know that you understand how permission actually work, and not just that you can attach a policy to a role and call it done. Interviewers will dig into how you think about giving people and services and applications the minimum access that they need, how you'd set up access across multiple accounts, and how different types of policies interact with each other. IAM, Identity and Access Management, goes into S tier. AWS organizations is next. Now, AWS organizations lets you manage multiple AWS accounts under one single umbrella. Now, if you're thinking, why would a company need more than one account? In the real world, companies don't run everything in a single AWS account. If something goes wrong in one area, you want it contained so it doesn't take up everything else down with it. So companies have to separate accounts for different purposes: one for production, one for testing, one for development, one for security, and so on. Now, organizations lets you set rules that apply across all of those accounts at once. So you can enforce things like nobody in an account is allowed to turn off logging, or only the security team can make certain types of changes. So it's really important for larger companies, but it's something that you set up once and adjust occasionally. It's not daily work, right? Now, in interviews, the concept of multi-account strategy comes up, but organizations itself isn't a deep standalone topic. So AWS organizations goes into C tier. KMS. KMS stands for Key Management Service, and it's how you handle encryption in AWS. Now, encryption is basically scrambling your data so that if someone gets access to it without permission, they actually can't read it, right? So think of it like putting your data in a locked safe. KMS creates and manages the keys to that safe. Every piece of sensitive data in AWS should be encrypted. Customer records, financial data, personal information, all of that. And KMS is what powers that encryption behind the scenes. You'll interact with it very often, but also sometimes without even realizing it. When you encrypt files in S3, KMS is handling the keys. When you encrypt a database, again, it's KMS. Fundamentally, it's woven into almost everything, but you're not in the KMS console every single day, but it's always there, quietly doing its job. So how deeply do you need to understand KMS? Well, fairly deep. You need to understand how encryption keys are managed, how key rotation works, and how you share encrypted resources across different accounts, and how you can track who accessed encrypted data and when they did it. Now, we were working with a client in financial services, and during a compliance review, it came up that the encryption keys hadn't been rotated in nearly 2 years. Key rotation is basically the practice of regularly changing your encryption keys, so if the keys ever compromised, the window of exposure is limited, and they hadn't done it in 2 years, increasing their risk of being compromised. So, does KMS come up in interviews? Yes. Interviewers will test whether you understand encryption as part of your overall architecture. They want to see that you can think about data protection from the start, not as something that you bolt on afterwards. Now, if you're going for a security-focused role, expect deeper questions around how key management works and how you design it for a complex environment. So KMS goes into A tier. Then we have Secrets Manager. So Secrets Manager stores sensitive information like database passwords, API keys, and tokens instead of hard coding a password directly into your application's code, right? That's a big no-no, a massive security risk, and something I still see companies doing in 2026 when I'm reviewing their environments. You store it in Secrets Manager, and then your application retrieves it securely when it needs it. It also automatically changes passwords on a schedule, so you don't have to do it manually. Now, every production environment that I've worked in uses Secrets Manager, but it is straightforward. You store a secret, you retrieve it, and you set up rotation. In interviews, it comes up as part of a broader conversations about how you manage sensitive information rather than a deep standalone topic. Secrets Manager goes into B tier. Guard Duty. Guard Duty is AWS's threat detection service. Think of it like a security camera system for your AWS environment. It watches for suspicious activity, things like unusual login patterns or someone trying to access resources they shouldn't be, and it alerts you when something looks off. So you could turn it on, you can configure your alerts, and it runs in the background. It's important to know about, but the depth here isn't required unless you're specializing in cloud security, which most of you watching this aren't ready for because you don't even have the experience yet. So Guard Duty goes into C tier. Security Hub. Security Hub pulls security findings from across your AWS environment into one central dashboard. So instead of checking multiple different services to see if anything is wrong, Security Hub brings everything together and also runs automated checks against industry security standards. Useful for larger environments, but for the same reasons as Guard Duty, Security Hub goes into C tier. Then we have WAF. WAF stands for Web Application Firewall, and it protects your web applications from common attacks. Things like someone trying to manipulate your database through a web form, or flooding your app with so much traffic that it goes down. You put the WAF in front of your application, and it filters out malicious traffic before it reaches you. So you need to understand what WAF does and when to use it, but security teams often own the specific rules, and most cloud engineers aren't deep in WAF configuration daily. So WAF goes into C tier. And by the way, if you're serious about landing a 6-figure cloud role in 2026, then simply just check the link in the description below and book a call with my team. I've had students learn cloud engineering with me and land roles across tech. Some went into DevOps, Mac went from IT help desk to AWS as a systems engineer. John had no experience and now he's working for AWS in their consulting division. Silas switched careers at 42 and he's now working as a platform engineer. Eddie moved from a non-technical cybersecurity role to a hands-on cloud security role with a 72K pay rise. Dominic got hired as a cloud DevOps engineer at Siemens. So if you're serious about landing a cloud role in 2026, then just simply check the link in the description below and book a call with my team to see if we can help you. So let's move on to networking and content delivery. This is definitely one of my favorite parts of AWS, starting with VPC. Now, VPC stands for Virtual Private Cloud, and it's your own private network inside of AWS. Now, imagine AWS as a massive building with millions of tenants. VPC is your own private floor with your own walls, your own doors, and your own security system. Nothing comes in or goes out unless you explicitly allow it. In terms of how often you use it, it's right up there with identity and access management. So I'll give you a real example. We were brought in to help a client whose internal application had suddenly stopped working. What had happened was that someone had been cleaning up unused resources to save money, which is the right thing to do. And in the process, they somehow removed a VPC endpoint. Now, a VPC endpoint is what allows your services to communicate with each other privately without the traffic having to go over the public internet. So once that endpoint was gone, the service that depended on it had no route to each other. Traffic was essentially hitting a dead end. We identified it through the VPC flow logs, which showed the traffic being rejected. We spun up a new endpoint, updated the routing configuration, and the application was back up within about 15 minutes. Now, does VPC come up in interviews? It's actually one of the most heavily tested areas. Interviewers will ask you to walk through how you design a network for a production environment. And what they're really testing you here is whether you understand the reasoning behind the networking design. Why do you separate certain parts of your network? How do you control what traffic goes where? How do you allow your servers to reach the internet without exposing them directly? They are testing your mental model of how everything connects, not just whether you can just list the components. So how much knowledge do you really need here? Well, it's a lot. You can't get away with service level understanding. Subnets, route tables, gateways, security groups, access controls, peering endpoints, flow logs, all right? Then you really need to know how these pieces all come together. So VPC goes into S tier. Route 53. Route 53 is AWS's DNS service. DNS is a system that translates website names into actual addresses that computers use to find each other. So when you type google.com, DNS figures out where Google servers are, so your browser knows where to go. Route 53 is how you manage that for your own applications on AWS. Route 53 also monitors whether your servers are healthy and can automatically redirect users if something goes down. If you have servers in 2 regions and one fails, Route 53 sends everyone to the working one. It can also route users to whichever region is closest or fastest for them. So you'll configure Route 53 very often. Every time a company launches something new or sets up a multi-region architecture, DNS is definitely part of the conversation. So it's not daily work, but it comes up frequently enough that you need to be confident with it. Does it come up in interviews? More often than people expect. Interviewers will present failover scenarios where your routing choices directly impact whether user experiences downtime. So it reveals whether you understand networking at a practical level or just at a theoretical one. So Route 53 goes into A tier. CloudFront. CloudFront is AWS's content delivery network. If your servers are in London and someone in Sydney uses your application, then the request travels halfway around the world and back, which makes things super slow for customers. CloudFront fixes this by caching copies of your content at locations around the world, closer to your users. Any company with a global audience is probably using a CDN. You'll set up the distributions, you'll configure caching, you'll manage security certificates, and you'll connect CloudFront to wherever your content lives. Does it come up in interviews? Absolutely. When an interviewer asks you how you'd serve a global audience with low latency, CloudFront is central to the answer. They'll also test whether you understand what happens when you need to update content that's already been cached everywhere, and how you'd secure your origin so it's only accessible through CloudFront. So CloudFront goes into A tier. API Gateway. API Gateway lets you create and manage APIs at scale. So if you're new to tech, an API is how different software systems talk to each other. When an application on your phone pulls data from a server, that's happening through an API. API Gateway sits in front of your backends and handles who's allowed it, how many requests that they can make, and where those requests get routed to. In serverless environments, API Gateway is especially important because it's an entry point. A request comes in from a user. API Gateway checks it and sends it to the right place for processing. Does it come up in interviews? It absolutely does, especially for anything involving serverless. So interviewers want to see if you can think through building a scalable API, securing it, and protecting the services behind it. They will also test whether you understand the trade-offs that you need to make between using an API gateway with serverless versus running your own API server behind a load balancer. So API Gateway goes into A tier. Elastic Load Balancing. Elastic Load Balancing distributes incoming traffic across multiple servers. So think of it like a traffic controller at a busy intersection. AWS has different types depending on the situation. One understands web traffic and then can make smart routing decisions based on what the user is requesting. Another one handles raw network traffic with minimal delay, which matters for applications that need real-time responses. So choosing the right type matters a lot. I've worked in environments where the team had picked a load balancer that was inspecting every single request in detail when all they needed was something that just passed the traffic through as fast as possible. So the extra processing was adding unnecessary delay. Switching to the right type of load balancer made a noticeable difference. Now, does it come up in interviews? It definitely can. Interviewers might want to see that you understand why you choose one type of load balancer over another and can explain the reasoning behind it. They'll present scenarios where your choice directly affects the performance and the availability of the system. So Elastic Load Balancing goes into A tier. Okay, next up, we've got compute, starting with EC2. EC2 is your virtual servers in the cloud. So instead of buying a physical server, you spin one up on AWS in about 60 seconds. You choose how powerful it is, what it runs on, and where it's located. When you don't need it, you can just shut it down and stop paying. Now, everyone talks about serverless and containers in 2026, but EC2 is still the backbone of the majority of production workloads. Most companies still run on EC2, so you'll use it extremely frequently in your day-to-day. The depth here has to be enormous. There are dozens of server types designed for different types of workloads. Some for heavy compute, others for applications needing lots of memory, others for data processing. So picking the wrong one means that you're overpaying or you're underperforming. So you also need to have an understanding of pricing because EC2 is one of the biggest areas of cloud waste. I've worked with companies running everything on the most expensive pricing model because nobody took the time to look at their usage patterns. We identified what was running consistently, committed those to a discounted plan, and then the savings were substantial. Does EC2 come up in interviews? Well, extensively. Interviewers want to see that you can design systems that stay running when servers fail, that you understand auto-scaling, and that you can choose the right server type for a workload and explain why. They will also test pricing knowledge because cost awareness separates junior engineers from senior ones. EC2 goes into S tier. Lambda. Lambda is serverless compute. You can write your code, upload it, and AWS will handle everything else. So no servers, no patching, and no capacity planning. You only pay when your code actually runs. So this is the classic event-driven architecture. Something triggers your function, a file uploaded, an API request, a message in a queue. Lambda runs your code, returns your results, and shuts it down. 1,000 triggers at once, well, Lambda runs 1,000 copies. It scales without you doing anything, and Lambda is everywhere in a modern AWS environment. Automation, API backends, data processing, scheduled tasks. So even if your main application runs on traditional servers, you'll likely have Lambda handling things around it. So how much do you need to know? Well, a lot. Because Lambda has some real constraints. There's a cold start delay when it spins up fresh environments, functions can only run for 15 minutes max, and there are limits on how many you can run simultaneously. And connecting Lambda to private resources requires specific networking setup. Now, I've seen teams build an entire processing pipeline on Lambda without even thinking about those limits. It works perfectly fine in testing. They launched it, traffic spiked, and they hit the limit, and then functions started getting rejected. Events backed up, and processing stopped. That kind of failure that comes from not understanding the constraints or your use case properly. Does Lambda come up in interviews? It comes up constantly. Interviewers love Lambda because it tests multiple things at once. Can you design event-driven systems? Do you understand the constraints? Can you explain when Lambda is the right choice and when servers or containers would be better? Lambda goes into A tier and just misses out on S tier because not every environment runs serverless. ECS. ECS stands for Elastic Container Service. A container is a way that you package up your application with everything that it needs into one self-contained unit that runs the same everywhere. Think of it like a shipping container, right? Standard shape, works on any ship. ECS run those containers at scale on AWS. And it has two modes. One, where you manage the servers underneath, and Fargate, where AWS handles that entirely. Fargate is popular because it removes server management completely. Loads of companies run containers in 2026. In interviews, container questions are common, and interviewers want to see that you understand the operational side. So ECS goes into B tier. EKS. Elastic Kubernetes Service. Kubernetes is the industry standard for managing containers. Incredibly powerful, but it's also incredibly complex. Many companies don't need it because ECS handles their needs without the overhead. Larger companies wanting portability across cloud providers often choose Kubernetes, but the number of roles requiring deep Kubernetes knowledge is smaller than most people think. For those of you starting out or looking to learn AWS to level up your career, you won't need to know this service right now, maybe further down the line once you're much more experienced. But it is a cornerstone service that big tech companies use, so I'm putting EKS into B tier. Now let's move on to storage, starting with S3. which stands for Simple Storage Service and is one of the most common services that you'll use when building on AWS. S3 stores files of any kind: documents, images, videos, logs, backups, datasets, with extraordinary reliability, essentially guaranteeing that your data won't be lost. I've basically never worked on a single AWS project that didn't use S3. You'll use it every single day. It's virtually in every architecture. And how much do you need to know? Well, a lot. Because one of the most important things in S3 is storage classes. S3 has different pricing tiers based on how often you access your data. Frequently used data goes into the standard tier. Data that you touch rarely goes into much cheaper archival tiers. And you can set up the rules that move data automatically as it ages. Now, the number of companies that don't do this is staggering. I've worked with organizations that had years of old logs sitting in most expensive tiers because nobody set up those rules. Simple tiering policy, significant savings, runs on its own once configured. Now, beyond storage classes, you need to understand access control, versioning to recover deleted files, replicating data across regions for disaster recovery, and event notifications that trigger actions when files are uploaded. Does it come up in interviews? Absolutely does, pretty much from every single angle. Cost, optimization, security, data management, architectural balance. Interviewers want to see that you can think about S3 as a core part of your architecture, not just somewhere that you dump files. So S3 goes into S tier. EBS. EBS stands for Elastic Block Storage. It's the storage that attaches to your virtual servers. Think of it as a hard drive for your cloud server. Every server needs at least one, and it's a managed service. So AWS handles the underlying hardware. You just choose the type and the size, right? And that matters because not all storage is built the same. Some workloads just need basic storage, like a simple web server serving pages, but a database that's processing thousands of transactions per second needs storage that can keep up with the constant reading and writing at high speeds. I've worked through database performance issues where everything pointed to a database being the problem, but it wasn't, right? The storage underneath it was the bottleneck. The volume wasn't built for the intensity the database needed. So during busy periods, everything slowed down dramatically. So we switched to the right volume type and it fixed the problem immediately. Now, does it come up in interviews? I wouldn't say that it comes up very often. You do need to have an understanding where a performance issue is actually coming from. So is it the server, is it the network, or is it the storage? So EBS goes into B tier. EFS. EFS stands for Elastic File System, a shared file system that multiple servers can access at the same time, like a shared folder on a network. Now, useful for specific situations, but most modern setups use S3 or EBS instead. Rarely a standalone interview topic, so EFS goes into C tier. Next up, we've got databases. RDS. RDS stands for Relational Database Service, a managed database in the cloud. Instead of setting up a database server yourself, installing software, managing updates, handling backups, and failures, AWS just does it for you. Cheers. You choose your database type and RDS handles the rest. Relational databases are still the backbone of most business applications. Banking, e-commerce, enterprise software, right? RDS is how most companies run them on AWS, and you'll work with it constantly. How much do you need to understand? Well, you need to have solid depth in it. You need to know how to make your database highly available, meaning if the server is running fails, a backup takes over automatically. Some homework, go check out how AWS does this with RDS. Now, you also need to understand how to handle heavy traffic by creating read-only copies that take the load off the main database. These are two completely different solutions to two different problems: availability versus performance. Now, be careful here and don't mix them up, as this is one of the most common mistakes in interviews. Does it come up? Yes, it absolutely does. Interviewers use databases to test whether you can design reliable systems. The availability versus performance distinction is a classic test of whether you generally understand the concepts or you just memorize the service names. RDS goes into A tier. DynamoDB. DynamoDB is AWS's NoSQL database. So instead of structured tables with rows and columns, you store items with a key and retrieve them by that key. Incredibly fast, single-digit milliseconds at virtually any scale. It's fully managed, there is no servers, and there is no maintenance. DynamoDB is everywhere in modern AWS environments, especially service environments. Even environments that mainly use traditional databases often have DynamoDB for specific things like user sessions or real-time data. How much do you need to know? Well, it really depends on the specific role that you're applying for. You're not expected to be a database administrator, but you do need to know how designing a DynamoDB database is fundamentally different from a traditional one like RDS, as well as the trade-offs like cost implications that come up with the speed that you get. So yes, this will come up in interviews and it is a core AWS service that you need to understand, but you won't necessarily be using it day to day, and it depends on the actual role that you have. So DynamoDB goes into A tier. Aurora is AWS's custom-built database engine. With RDS, AWS is taking existing database engines like MySQL and handling the heavy lifting of running them. Aurora is slightly different. AWS actually built their own engine from scratch, designed to be faster, more resilient than those standard engines. But they made it compatible with MySQL, right? So if your application already uses those, it can switch to Aurora without having to change any code. So what makes it better? Well, performance and redundancy. Aurora automatically stores your data across multiple locations. So if one fails, your database keeps running. It can also scale its read capacity automatically when more users start hitting the database. For companies wanting the best database performance on AWS without managing the complexity themselves, Aurora is typically recommended, and work with Aurora feels very similar to RDS. That said, you won't encounter Aurora anywhere near as often as some of the other services that we've mentioned, so Aurora goes into C tier. ElastiCache. ElastiCache is AWS's managed caching service. So every time a user loads a page, the application goes to the database, it runs a query, and it gets the data, and then it sends it back. That's fine when it happens occasionally. But imagine thousands, if not millions, of users all requesting the same information simultaneously, like a product page or a leaderboard. Your database is then answering the same question over and over again, which slows it down, and then it wastes resources and cost. Caching solves this. So instead of going to the database every single time, you store the result of that first query in fast memory. Memory is significantly faster than a database because there is no searching, retrieving, or processing involved, right? The answer is just sitting there ready to go. So the next thousands or million users who ask the same question get the answer almost instantly, and your database doesn't even get touched. So ElastiCache is handling that caching layer for you. It's a managed service, so you don't set up or maintain the servers that run the cache. You just configure it and you just point your application at it. When it comes to interviews, caching as an idea comes up everywhere, and you need to understand why it matters, but you don't need to spend too much time learning this service because it's quite straightforward. ElastiCache goes into C tier. So let's move on to serverless and application integration, starting with SQS. SQS stands for Simple Queue Service. In any system, you've got different parts that need to talk to each other. A payment service needs to speak to an order service that the payment has gone through. A user service needs to tell the email service to send a welcome message. The simplest approach is to have one part directly call the other. But what happens if the receiving part is down or overwhelmed? That call then fails, right? The sender doesn't know what to do, and things start to break. A queue solves this. Think of it like a line at a restaurant. Orders come in, go into a queue, and the kitchen works through them one by one. If the kitchen is backed up, then the orders wait. Nothing gets lost. SQS does exactly this between services in your architecture. Now, one part sends a message, another one picks it up when it's ready. If the receiver is busy or temporarily down, messages wait safely in the queue until it comes back up. This concept is called decoupling, separating your components so they don't directly depend on each other being available at the exact same moment. This is fundamental to building reliable systems. I've used SQS on projects where it made a big difference between handling traffic spikes and collapsing, a payment system that needed to absorb sudden burst, the front end accepted payments and then dropped them into the queue. Processing happens steadily on the other end. No payments were lost and no crashes. But how often will you use it? Well, you use it fairly often. Queues appear in most production architectures. How deep do you need to go? Well, you need to understand the concept really well and when to use it and how it fits into the system design. Now, you don't need to memorize every single configuration option here. Does it come up in interviews? Absolutely it does. Decoupling is an important concept. Interviewers want to see that you understand why you separate components and what the trade-offs are. So SQS goes into B tier. SNS. SNS stands for Simple Notification Service. SQS is one-to-one, right? One sender, one receiver picking up messages off the queue. But what if something happens and multiple parts of your systems need to know about it? A new order comes in and the payment service needs to know. The inventory service needs to know. And a notification service needs to send the customer an email. You could have the sender put a message into 3 separate queues, but that means the sender needs to know about every downstream service, which defeats the purpose of decoupling, right? So SNS solves this. One message goes out, every subscriber gets a copy. One to many instead of one to one. The sender publishes once and doesn't need to know or care who's listening. SNS and SQS are often used together, and this is a pattern worth understanding. Something happens, SNS broadcasts to multiple SQS queues, and each queue feeds a different process. The sender stays simple, the receivers stay independent, and you can add new subscribers without touching the original service. How often will you use it? Well, pretty frequently, usually paired with SQS. How deep do you need to go? You need to understand the concept and the SNS and SQS pattern. The service itself is pretty straightforward. Does it come up in interviews? Yes, it does. You'll need to know the differences between one-to-one and one-to-many messaging and when to reach for each. SNS goes into B tier. Event Bridge. Now, Event Bridge is AWS's event routing service. If SQS is a queue and SNS is a broadcast, Event Bridge is a smart router. Events flow in from AWS services your own applications, and even third-party tools, and then you set up rules that decide where each event should go based on its content. So instead of hard coding which service talks to which one, you define rules centrally and Event Bridge handles the routing. Picture a post office sorting room. Letters come in, get sorted based on the addresses and time, and get routed to the right destination. The sender doesn't need to know exactly where things end up, right? You define the rules. It's the backbone of event-driven design. How often will you use it? Well, it depends on the organization. Teams building event-driven systems use it heavily, but not every cloud engineer works with it daily. Does it come up in interviews? Yes, it does, but it's still emerging as a new direct interview topic, right? But more companies are asking about event-driven architecture generally. How deep do you need to understand it? Well, you need to understand what it does and why event-driven design matters. Event Bridge goes into B tier. Step functions. So step functions build workflows that coordinate multiple services. Think of it like a flowchart that you can actually run. If this step succeeds, do the next thing. If it fails, retry it or handle the error gracefully. Each step can call a different AWS service, a Lambda function, an API, whatever the workflow needs. Why does this matter? Well, some processes have multiple steps that need to happen in a specific order with logic in between. Processing an insurance claim, for example, right? You need to validate a submission, you need to check for fraud, you need to route to the right department, and you need to send a confirmation. You could wire all of that together manually in code, but step functions gives you a manageable way to define the entire workflow with built-in error handling and retries. How often will you use it? Well, it's specialized. You will encounter it in organizations with complex automated processes, but most cloud engineers don't touch it daily. Does it come up in interviews? Well, it does occasionally, usually when discussing how you design a multi-step workflow. How deep do you need to go? Well, you need to know what it does and when you've reached for it. Step functions goes into B tier. DevOps and deployment. CloudFormation. So CloudFormation is AWS infrastructure as code service. So instead of manually kicking through the console to create resources, you write a template describing what you want and CloudFormation builds it. You change a template, you submit the change, CloudFormation will then figure out what to do and what to update. So it's a blueprint for your infrastructure that you version control and you deploy consistently every single time. Whether it's CloudFormation, CDK, right, or Terraform, which many teams still use because it works across cloud providers, managing infrastructure through code is how real engineering teams actually operate. You'll do it frequently. How much do you need to understand? You need to understand it significantly. You need to know how to organize templates, preview changes before applying them, detect when someone's manually changed something that should only change through code, which we call drift, and recover when a deployment goes wrong. Now, that last one matters a lot. I've dealt with deployments that fail partway through and leave things in a broken state. So knowing how to recover, especially under pressure, is practical knowledge. Does it come up in interviews? Infrastructure as a code is a core topic. Interviewers want to know that you can manage infrastructure programmatically and understand why it matters, right? It's expected at this point. CloudFormation goes into A tier. Next, we've got a group of AWS services: Code Pipeline, Code Build, and Code Deploy. Code Pipeline manages your deployment pipeline, right? Code Build compiles and tests, and Code Deploy automates deployment. The thing is, most companies use third-party tools like GitHub Action, Jenkins. That said, the concepts behind these are important though. Automated pipelines, deployment strategies, when you spin up a new version alongside the old one, and gradually shift users over time. Automatic rollback if something breaks. Those concepts are essential knowledge. The specific AWS services, most companies aren't using them. Code Pipeline, Code Build, and Code Deploy go into F tier. Learn deployment strategies inside out, but don't spend too much time mastering these tools unless your company uses them. CloudWatch. CloudWatch is a monitoring service for everything in AWS. So if something is running in your account, CloudWatch can track it. It's how you know whether your infrastructure is healthy or whether something is quietly going wrong because your users start complaining. What does it actually track? Things like how much CPU your server are using, how many errors your applications are generating, how fast your APIs are responding. It also stores the detailed logs your application produce. So when something breaks at 2 a.m., you can go back and see exactly what happened leading to it. And you set up alarms that notify you when something crosses a threshold, like CPU usage spiking above 90% or error rates suddenly doubling. How often will you use CloudWatch? Well, very frequently. It's the first thing that I look at when troubleshooting. How deep do you need to go? Well, pretty significantly. You need to understand custom measurements, building dashboards that actually tell you something useful, querying large volumes of logs efficiently, and setting up alerts that people will actually act on. The last one is harder than it sounds. Getting the balance right takes experience, and it's something interviews specifically look for. They call it alert fatigue. Does it come up in interviews? It can, yes, right? Interviewers test whether you can design a monitoring strategy, right? They want proactive thinking about observability, and they want to know that you've considered the human side too. CloudWatch is critical for visibility, but it's a tool that you use to observe your infrastructure and not something that you build your infrastructure around. CloudWatch goes into A tier. CloudTrail. CloudTrail tracks every action taken in your AWS account. Someone creates a server, changes security setting, deletes a file, it's all logged. Who did it, when they did it, and where they did it from, and exactly what happened. How deep do you need to go? Well, you need to understand how to search and filter trails effectively, how to set them up across multiple accounts, and how they fit into incident response. It's not complex to configure, but it's about knowing how to use it when it matters. That's the actual skill here. Does it come up in interviews? It does, yes. You need it for security-specific roles. Interviews want to know, do you understand audit trails and can use them during investigations, right? And know how to set them up across the organization. So CloudTrail goes into A tier. AWS Config. So AWS Config continuously checks whether your resources are set up the way that they should be. CloudWatch monitors performance, CloudTrail logs who did what, and then Config checks whether things are actually configured correctly according to your rules. Say your company has a policy that all storage buckets must be encrypted and no server should be open to the entire internet. You define those rules in config, it watches every resource in your accounts, and the moment that something fails and falls out of line, whether someone changed it manually or a deployment introduced it, config flags it. It can even show you a timeline of how a resource configuration has changed over time. So you can see exactly when something drifted and where it should be. It's not something most cloud engineers are deep in daily, and there will be another engineer that will probably take care of this. So having service level knowledge here is enough. AWS Config goes into F tier. Cost Explorer. Cost Explorer shows where your money is going in AWS. It breaks spending down by service, account, and region, and also tags, so you can see exactly what's costing you what. AWS estimates that the average company wastes 30% or more on cloud spend. That's not a small number, right? So when you can find that waste and eliminate it, you're directly impacting the business in a way that the leadership notices. So one of the common things that I find is companies paying for data transfer they don't need to. AWS charges for data moving between services, between AZs and regions, right? If your architecture routes traffic through an expensive path when a cheaper one exists, that cost builds up quietly month after month. Nobody notices until someone finally looks at the bill. Cost optimization is a critical skill, but companies will now have a dedicated FinOps engineer that takes care of most of this, right? So having service level knowledge of this service is very, very important. So Cost Explorer goes into F tier. AI and ML. So Bedrock is AWS's managed service for building AI applications. Right now, every single company is trying to figure out how to use AI, but most of them don't want to build their own models, LLMs from scratch. That's incredibly expensive, and it requires specialized AI expertise that most people don't have and most teams don't have, right? But what they want is access to the most powerful models that already exist and the ability to build applications on top of them. That's what Bedrock gives you. It's a single point of connection to AI models from Anthropic, Meta, and others, right? You pick the model that fits your use case, you connect to it and through Bedrock and build your application. And AWS will handle all the infrastructure underneath. So you're not managing servers, you're not setting up GPUs, you're not dealing with the whole model hosting, you just build what you need, right? How often we'll use it? Well, it's growing fast. According to AWS, over 100,000 customers are already building on Bedrock. Everything from contract analysis to customer service automation to code review to bots, right? This number is already going up, and AI is a trend that isn't going anywhere. And Bedrock is becoming the standard way companies deploy AI on AWS because of the privacy that AWS gives you. Does it come up in interviews? It does increasingly. Interviews are starting to test whether you can think about AI as a cloud engineer. How do you secure access to them, right? How do you control who can use which models? How do you monitor usage and manage costs? Most people haven't wrapped their head around it. So if you can do that, you'll stand out. Bedrock goes into A tier. SageMaker. SageMaker is AWS's machine learning platform. When Bedrock gives you access to models that already exist, SageMaker is for building your own models from scratch. As a cloud engineer, you might set up the infrastructure around SageMaker, but the actual building and training of the models isn't your job unless your role specifically crosses into machine learning territory. How often we'll use it? Well, not really much, right? Unless you're specialized in a machine learning focused role. Does it come up in interviews? Not really. Again, for cloud engineering positions, interviewers don't really expect you to know how to train models. How deep do you need to go? Well, you need to know what it is and how it fits into the wider AWS ecosystem so you're not caught off guard if something is mentioned. That's it. SageMaker goes into F tier. So here is a final tier list. S tier, IAM, VPC, EC2, and S3. A tier, Lambda, RDS, DynamoDB, Elastic Load Balancing, Route 53, CloudFront, API Gateway, CloudFormation, CloudTrail, CloudWatch, KMS, and Bedrock. B tier, ECS, EKS, EBS, SQS, SNS, Event Bridge, Step Functions, and Secrets Manager. C tier, Guard Duty, Security Hub, WAF, EFS, AWS Organizations, Aurora, and ElastiCache. F tier, Code Pipeline, Code Build, Code Deploy, Cost Explorer, AWS Config, SageMaker. Now, if you need my help to land a six-figure cloud role, check the link in the description below and book a call with my team. As always, I'm rooting for you. Good luck.